All right, nothing
Welcome
else?
back to math class.
Makes sense.
This has been an interlude.
They don't know that.
What's been an interlude? Video?
Yeah.
Oh yeah, she paused it.
No, I deleted the old one and I started
Oh
this
good,
one.
yeah, because we were that was a little bit.
Oh no, I paused it before we started talking
Basically,
about
that's what
that.
I've done in all three classes, just kind of walk around and hitting
Hitting the students.
Yeah, hitting students. That's what we do.
Yes, get a little closer to the camera so they can hear you.
Just kidding.
The government's watching. Everyone's watching.
Tomorrow night.
You will not be here.
Katie has a softball game.
No. No games till next weekend. But tomorrow night, Lizzie has been asked to speak. She's always asked to speak to the Make-A-Wish Foundation. So she goes to the Wish House and is speaking to the board about her wish and stuff like that.
Where is she? What's her wish?
Well, we already had it. It's about a year and a half ago. She wanted to be a princess at Disney World.
Oh yeah, you told us about that.
So, yeah, that's right. You weren't here last year.
No.
There was an assembly the Friday right before fall break. And, you know, it was a standard assembly, but they also did some Make-A-Wish stuff. And Lizzie came. And she was in her Cinderella dress.
Oh.
And she was supposed to get up and speak, and she was a little nervous, which is understandable. At that point, she was an 8-year-old in front of 2,000 people. So I got up there with her, and we were in the middle of the basketball court, and I just knelt down next to her and held the mic and asked her a few questions, and she talked like this, and everybody loved her. So it was really cool. Yeah, that was last school year, so most of you were freshmen then.
Oh, yeah, I remember that.
You didn't realize that was Lizzie, did you?
No, I didn't. Until I saw you. Until I found. Well, yeah, I didn't know it was your daughter. And I saw the picture. I was like,
And then, yeah, 2 days later we left. They sent a stretch limo for us. Everything that they did was awesome, like insanely awesome. They stretch limoed us to the airport. Then we were flying Southwest. Southwest brought us on early. They had somebody hanging there with us, gave Lizzie some presents and that. They let us go to the cockpit. You know, they let us be the first people on board and went to the cockpit, and Lizzie was checking things out and stuff like that. They let her take off with the plane, and no, I'm just kidding about that part.
Oh, that would be like, whoo.
No, but they were awesome. Everything they did was fantastic. I wholeheartedly, you know, people that volunteer there or donate there or whatever, I could not think of a better organization. They're fantastic. So. Okay, I know we're going. So the reality is that we did most of what we needed to do today. Yes. Yes. So today, what we're going to do is we're going to start by kind of concluding what we need to do today. And then we're going to jump into tomorrow's stuff, because tomorrow's stuff is actually long, and it's a Wednesday, and there's probably not enough time to do it right. So we'll start doing it today, and that should make tomorrow a lot easier. Things like that. Okay?
Okay.
We would like to graph this system of inequalities. Okie dokie. So, away we go. Three variables? No. I cannot draw a three-variable graph, a three-dimensional graph. That would be problematic.
I draw three-dimensional graphs.
Yeah, some people can. Some people
Really?
can figure out, because if you draw the third axis kind of like this, it almost looks like it's coming out. But I can't do that. Katie might be able to do that because she has artistic talent. I
artistic
have
talent.
exactly 0 artistic talent.
Same.
All right, go.
Okay, yeah, right.
No, you can't.
Go.
That was a very cringe drawing I did.
Yeah, and something I want to touch on, that's a good point.
You so much right
There
now.
are a few different ways to start to graph the first inequality, x plus y is less than 4. A lot of you will probably start to throw it into slope-intercept form.
Don't.
To me, I'm always going to do what I think is the easiest. When I see x plus y, just plug in numbers. You know what I mean? Instead of changing the slope-intercept form where you might make a sign mistake or something like that, just plug in some numbers. Like?
0.
Okay, what are we graphing? When we're graphing x plus y is less than 4, what's the first thing we're doing? We're graphing x plus y equals 4. Right? The line is the separator. Remember we talked about that yesterday. The line is the separator. The line separates greater than from less than. And the line has to be equals. So we have to graph x plus y equals 4 first. So, talk to me. Without your phones. Hint, hint. 0, 4. 4, 0. That's all we need.
Wait, really?
Yep, really.
Dang.
We could have done 3, 1 and 2, 2 and all that stuff, but I mean they're just all on the same line. So for me, like I like intercepts. They're simple, simple, simple. And x plus y is even simpler than that. So that's just the way I look at it. All right, now what? Dotted. Dotted. Why dotted? Because there's no equal, it's just less than. Ethan was right. Did you believe that? No. That's kind of the way I feel sometimes. All right, so now what?
We shade.
We got to shade that, don't we? I wouldn't. I would do each one as it comes. You can. I wouldn't, because like once you start to get 3 lines and lots of different sections in there, now you're going to have like 6, 8, 9 different sections of graph. And so are you going to pick a point from every section until you find it? You know what I'm saying? Just do it as you're going along, it'll be easier. So which side are we going to shade? How are we going to decide which side to shade?
Plug in a point.
Plug in a point. What point?
0, 0.
I would pick 0, 0 here. 0 is less than 4. By the way, here's 0, 0 below the line. 0, 0 made it true, so let's shade below the line. Okay? Now, the more of these you get, here we have 3. Later on, we're going to do something with 4. Okay? Be very careful about how you shade. Just make it nice and light, or just make sure that you know which side you're shading. Okay? Don't go crazy, because you're going to have a lot of stuff going on here. Okay?
You just said don't go crazy.
I know. I'm gonna do it in different colors though. I like colors.
Next. X equals 0. Tell me about it. It's on the line. It is the y-axis. Right? X equals 0 is a vertical line at 0, which in effect means the
Y-axis.
y-axis. Okay, so we're drawing the y-axis. Okay, how?
Dotted line.
Dotted. Now what?
Shade the right.
Shading time. Which side?
Right.
Right side. How do you know?
Because X is greater on the
X
right
is
side.
greater, yeah. Where is X greater than 0? This one you kind of know. So shade the right. Now, what I would suggest as you start getting more and more of these inequalities, the green, we're supposed to shade everything over here. I would suggest starting to shade only the part over there that's already been shaded. I don't want to have too much shading going on and trying to figure out what's the darkest of the shadings and stuff like that. Let's just, as we're going along, okay, this stuff is already out from the first one. So when we shade here in green, let's shade in green the stuff that's already shaded in black. Okay? So I would just do this part down here. Is that okay? Questions there? Confusion? No? Last one.
Y is greater than or equal to -1.
Y is greater than or equal to 1. Tell me about it.
Horizontal line through.
It's a solid line. It's a horizontal line through
-1.
Y equals 1.
through y equals 1. So y is 1 here. So horizontal, you said solid, correct? So we're doing y is greater than. So where are we going?
Up.
Above the blue line. So remember what we said. We're looking for stuff above the blue line that's already been shaded twice. What are we talking about?
That little triangle.
That little triangle. Now it's time to shade it nice and dark. Make sure that you are showing what your answer truly is. Is it obvious what our answer is here?
Yeah.
Yeah, I would think so. How do we write our answer on the test or something like that? The graph. The graph is our answer. That's all you'll need.
You put a little arrow and say, this is thine answer.
No way. Not a chance. Impossible. The only way you could write it with equations or inequalities is like this.
Just put that for our answer.
Which, yeah, writing the answer as the question probably doesn't help all that much.
You might just get a point docked, maybe.
All right. Questions here? Good? Okay. Let's move on.
You guys are like taking small areas of space. Here I am, just.
Anybody still need?
It looks. I don't know. I wanted a big graph. I like big graphs than I can now. I'm excited.
So that is the end of 9-4.
I'm going to
Okay?
code day.
So your homework tonight is going to be on that stuff. We're starting 9-5. We'll get a fair amount of the way through 9-5. We'll stop. We'll probably have 10 to 15 minutes left at the end of class for you guys to get homework done or whatever it is you need to do, or play on your phones for those that are constantly doing that anyway.
Hey, sometimes I like to color, man. Don't look at me like that.
I got you. I draw, dude. I can't judge you for doing art.
Should it have been?
Yes. The only art I can make is art that's already been drawn.
I can't color for the life of me, actually.
I like coloring.
I hate coloring.
Oh, that sounds painful.
Linear
Yikes.
programming. That is the name of the topic. Do not stress about it. I will explain it
Too
as
late.
we're going along. Too late. Is that what you said?
Yeah.
Well, does linear sound hard?
No,
Yes.
programming is what concerns
Oh, I like
me.
programming, but you should
Linear,
bring...
what does linear mean?
Graphing
It's lines. Well, you can deal with lines, right?
Yeah, I like programming, though. Programming's fun.
Programming lines.
So,
Pull out calculator.
here's the type of problem that you are going to be asked.
Else.
Here is a question in here. It says, find the maximum value of z equals 2x plus y with the following restraints. Subject to the constraint. I said restraints. Constraints. Subject to the constraints. I will explain it all as we are going along. X is greater than or equal to 1. I'm going to color code as much as I can.
Ooh, I like color coding.
X is less than or equal to 4. X plus y is less than or equal to 5. And y is greater than or equal to 0. The four inequalities that I wrote there at the bottom are called the constraints. Our job to get started is to graph that system of four inequalities. Okay? And then we will talk about what that thing up top means at the time we're done with that. All right? So step one is to graph this very colorful system. So,
I like colors.
let's get to work.
I don't like coloring, but I like colors. Big graph, little graph.
Fairly big.
Okay.
Accuracy is going to be a little more important here than normal.
Yikes.
Okay, where do we start?
X
S
greater than
greater than or equal to 1. Talk to me.
vertical line at 1.
Vertical line at x is 1. So here's where x is 1. We will draw a vertical line, and it will be solid. Okay, there?
In pink.
Now what?
Everything's to the right.
Shading.
Oh,
Don't forget shading. We have 4 inequalities. You do not want to be going very dark right now. Okay, take your time with it. But we are talking everything to the right. So, bless you. Okay with that? Black line is done. Now let's go green.
It's blue.
X is less than or equal to 4. Talk to me.
Vertical line.
Vertical line through x is 4. So here's where x is 4. What type of line?
Solid.
Thank you. Yeah, I know, that's what I was waiting for. Waiting for a straight line. All right, now what? Shading to the... So everything that should be shaded so far is in between the 2 lines. So we're talking more... Okay, blue.
Black.
X plus 5 is less than or equal to 5. X plus y is less than or equal to 5. There we go. Talk to me. 0, 5. 1, 2, 3, 4, 5. 5, 0. 1, 2, 3, 4, 5. Solid line. Ooh, that was pretty good. Just one line better. Last one was bad. No. Shading.
Everything
Below? How'd you figure that out?
0, 0.
0, 0. Plug in a point. 0, 0. 0, 0 is below the line. 0, 0 is less than 5. So good. So we're shading below the line. And now remember, let's just do below the line that's between the 2 lines. So let's... Is that okay?
yes.
Finally, y is greater than or equal to 0.
The x-axis.
Horizontal line, the x-axis. Okay, the x-axis, solid line. So a solid line on the x-axis,
Everything above.
everything above.
The shaded zone.
So we are talking about I would say that is not a triangle. What shape is it? Going back to your
quadrilateral.
geometry page.
Trapezoid.
It's a quadrilateral. It's a polygon, everyone.
It is a polygon.
Yes, it is. I'm not lying.
It is also a quadrilateral.
Yes.
It's a trapezoid. An irregular.
But the most specific answer to what shape is it is
It's a.
trapezoid.
I can't crack my neck right now.
Turn it on its side.
Yeah.
That'll look more trapezoidal.
What?
Okay. So, is it fair to say that this area in here is the area that makes all 4 of these inequalities true?
Yes.
This area in here, bless you. Bless you. It's called the feasible region. Because it is the
Feasible region.
the region that is
Feasible.
Let me go deep here. It is the region where everything is true. Okay? So, how are we doing? We solved the system of inequalities. We came up with the feasible region. Okay, what do you think we have to deal with now? These were the constraints. Okay. We now have to deal with this thing up top. Okay. And this thing up top is called the objective function. This is our key to this problem. What we want to do, depending on the question, is we typically either want to find the highest, the maximum value of the objective function, or perhaps the minimum value of the objective function. Maybe if the objective function represents the profit that we are going to make, we would like to maximize it. If the objective function represents the cost of making something, then we'd probably want to minimize it. If the objective function represented the area of the field, we would probably want to maximize that. Okay? If the objective function represented the cost of the fence to border the field, we would like to minimize it. So it depends on what it is that we're given. In this case, to get started, they're just saying, please find the maximum value of the objective function. So, it said it's subject to these constraints. So in other words, we want to find the maximum value of the objective function for any point that makes the constraints all true. In other words, for any point in the feasible region. With me there? Okay. So our job, therefore, is to just plug in all of the points in the feasible region into the objective function and see which one gives us the maximum value.
No.
That's a lot of points.
Why not?
That's a lot of points, man.
There's a lot of points. How many points are there?
Too many.
A lot, like 10?
No.
Less?
More.
More? More than 10?
Yep.
It's not that big a region. How many points are in there?
0.1. I'm kidding. Point.
Oh wait, we can do decimals too.
Yeah.
So 2 comma 1 is in the feasible region, correct? And 3 comma 1 is in the feasible region, and 2 comma 2 is in the feasible region. But so is 1.2 comma 1.783, and 1.2 comma 1.785, etc., etc., etc. How many points are in the feasible region?
Infinity.
An infinite number of points. So we better get started quickly then to check all of the points.
Yep.
No, not a really good idea.
Her. Just sipping her water.
Let me ask you this.
How do you feel?
It is.
How likely is it
Now it is.
that the maximum value of the objective function is at the point 2 comma 1? Why not?
No, it's just 1 point out of infinity.
True, it's 1 point out of an infinite number of points, and how do we make sure of that? But the other thing is that, would you say it's too low?
Towards the bottom of the page.
So you're saying that it's not likely that this would give us the maximum value because there are points above it.
And to the right.
Okay. Or there are points to the right of it? Okay. So there's always, in this case, there's always further you can go. So where would the most likely options be?
Either on the top or on the top.
Okay, can you give me a word? How about a word that starts with V?
Vertex.
Pluralize it.
Vertices.
The vertices. The vertices of the feasible region. How many vertices do you see in that feasible region? 4? I see one here. Yeah? I see one here. I see one here. I see one here. Do you see any more? I don't see any more either. Okay? Think of it this way. You just told me it was a trapezoid. How many vertices does a trapezoid have? 4. Now, it's not always going to be a trapezoid. Could be a triangle. Could be a pentagon. Could be a hexagon. I just don't know. You need to look and find the vertices of whatever the feasible region is. So here's the deal. One of those points will always give us the maximum value of the objective function. I don't care what the objective function is. One of those points will always give us the maximum value. And one of those points will also always give us the minimum value. Ooh, that helps. That just took us from an infinite number of points to 4. That's a pretty good move right there. You know what I mean? We had an infinite number of points, and now we only have 4. I could work with 4. So what do you think we do? Test the 4 points. Plug in the 4 points into the objective function. So to do that, we need to look at the vertices and find the coordinates, right? The coordinates of the vertices. So let's find the coordinates of the vertices. Let's see, that one, I feel pretty good about that being 1, 0. Some of these are going to be a pain in the neck to find because they're at the intersection of lines. And where are the intersections of the lines? And that's going to be always going to be a little bit interesting. We'll see a more difficult one like that tomorrow. Let's see, what about this one? Yeah, I like 4, 0. I feel pretty good about that one. How do you feel? You good there? What about this one? You like the 4? I like the 4. It looks like it's probably 4, 1. Are we sure?
No.
So let's talk about what it is that we're working with here. This point right here is the intersection of the green line and the blue line. The green line is x equals, right? The line is equals. So the green line is x equals 4, which therefore means that in this point, x is probably 4, right? The blue line is x plus y is 5. We know that x is 4, so therefore y is 1. So we thought it was 4, 1, but remember, I just put random points up there on the graph. It's not tremendously accurate. I feel pretty confident that the distance from 0 to 1 is not exactly the same as from 1 to 2, et cetera, et cetera. So it looks like 4, 1, but we don't know. We better make sure. I felt good about the 1, 0 and the 4, 0. This one, a little less so. All right, what about this last one? Looks like it might be 1, 4. Let's check it again. All right. The black line, right, this point is the intersection of the black line, which is x equals 1. So x has to equal 1. The intersection of the black line and the blue line is, oh, it's that x plus y is 5 again. So therefore, 1, 4. So we now know the vertices. How do you feel about the vertices? Good? Questions there? Okie dokie. What do we do with the vertices? Plug them all into the objective function. We want to maximize z. We want to find the maximum value of z. So, we got to plug them all in. Z, okay, so let's see. Yeah, let's do it this way. First point, let's do 1, 0. At 1, 0, z equals 2. I would agree. Let's go up to 1, 4. At 1, 4, z equals 6. I heard some 5s. I'm not sure where the 5s are coming from. Z is 6. X is 1. 2 times 1 is 2, plus y is 4, so 2 plus 4. All right, let's try 4 comma 0. Z equals 8. And then 4 comma 1 is our last one.
9.
Z equals 9. So, they asked us to find the maximum value of Z. Our answer is? No. Our answer is not 4 comma 1.
Oh no.
Our answer is 9. Because they asked us for
The value.
the maximum value of Z. The maximum value of Z is 9. They might ask us sometimes for the ordered pair that gives the maximum value of Z. If they asked us for the ordered pair that gives the maximum value of Z, what would our answer be?
4 comma 1.
4 comma 1. All right, what if instead of asking us for the maximum value of Z, they asked us for the minimum value of Z? What? Don't we have to redo the problem?
No.
Why not?
It has all the Z values.
Because the feasible region is the same, the vertices are the same, and since every maximum value or minimum value must be at one of the vertices, then we've already done all the work we have to do, and so the minimum value of Z is 2. And the coordinates that give us the minimum value of Z are 1 comma 0. Perfect. Let's say that this question had to do with the profit that we're earning if product X gives us a profit of $2 per unit sold, and product Y gives us a profit of $1 per unit sold. Right? $2 for each X, $1 for each Y. Would that be a fair objective function then? Is that okay? $2 for X and $1 for Y. And just before we were doing the presentation, just before we were getting ready to go on, the boss came in and said, "Are you ready?" I said, "Got it, we're good to go." And the boss said, "Only one problem, and I hate to do this to you, but our profit margins just changed. And we're now getting $3 for every unit of X and $2 for every unit of Y. So I'm really sorry to do that to you. So we've got 2 hours. You're going to be able to get it done in that time? And so here's what you do. How do you handle that? Do you go, "Yeah, boss, no problem"? No, here's what you say. You go, "I only have 2 hours to do that? Whew. All right. I'm going to do everything I can do to help. You know, it's going to be tough." The boss goes, "I know. This is a big deal, and I apologize."